Hi, I'm Dr. Cameron Sheeler with UAB's Biotechnology Program. Have you ever been working in the lab isolating proteins and you wondered, what is my protein concentration? Well, we're going to solve that problem right now by using our handy dandy standard curve. Meet me over at the board, please. All right, here we are. How are we going to set this up? Well, we have a known protein that we're going to make a standard with. What's that mean? We're going to use bovine serum albumin as our standard. We're going to set up known concentrations of BSA, 0.1, 0.2, 0.8, all the way to 1. We are going to take those samples, put it into our buffer that we use to lyse open our cells, and then we're going to read the samples in a spectrophotometer. Here I use 595 nanometers as our absorption, and we have our corresponding absorption. 0.4 milligrams per mil gave me an absorption of 0.5. Now you're gonna go, that is wonderful. What do we do with this now? We're gonna graph it. Yes, graph it. We're gonna set up a graph where our concentration is gonna be the x-axis and our absorption on the y-axis. And sometimes I get asked, Dr. Sheeler, which axis do I have to graph it on? Well, think about this. The y-axis is the dependent variable. The x-axis is the independent variable. That means these values depend on these values. So I know the concentration. Absorption depends on the concentration. That's how we graph this. Now we get our wonderful dots right here. Look at that. Now we go ahead and put our best fit line in for these, and we get this beautiful line right here, this regression line right here. This is going to be used to generate a line equation, and let's go over here. Sure enough, we have a line equation, but you know what? I also want to have an R-squared value. You're going to say, what is the R-squared value? I'm going to tell you. It determines how close your data fits to this line. Closer to the line, you're going to have an R-squared value to 1, which is the maximal value. Farther away from this correlation, it's going to be less than 1. Look what my R-squared value turned out to be, 0.9981. Pretty darn close. This is good. It's a good fit, and we can use this line equation. How are we going to use this line equation? Forgot to tell you. You also need to take a sample. We have 2 samples that we've done right here, and we have to get the absorption of our samples. Now, we're going to match that absorption up with this line, using that line equation to determine our concentrations. You're going to say, how? Good question again. You guys are full of good questions today. Let's flip it. Flip our board. Sample 1. Sample 1 has an absorption at 595 of 1. And you're going to go, great. Now what? Now remember, x-axis was our concentration. Y-axis was our absorption. This is an absorption value. We will use our line equation, put 1 in for y because it's absorption, and we're going to plug it into this equation. Look, I have already done this. 1 equals 1.0469x plus 0.0649. We are going to solve for x because x is what we're trying to determine, concentration. I'm going to move this over here, which means I 1 minus 0.0649 equals 1.0469x. We have to get x by itself. So now I'm going to put parentheses around this, order of operation, and we're going to bring this under here, making x by itself. We do all this. Let me get it in my head. Got it. It's 0.89 milligrams per mil. Our sample, for sample 1 that is, was, or is, not was, still is, 0.89 milligrams per mil. Now let's go on to sample number 2, shall we? Sample number 2, I get an absorption of 595 and the absorption is 2. Uh-oh, it's off scale. What do I mean by this? Let's flip this again. Look at our maximal absorption right here. It was 1.1, and I just said sample 2 was 2, which means we are off scale. To use a standard curve, you must use the parameters of that curve. Anything outside it, you will dilute it. So we're gonna dilute it to bring it back on scale. I actually diluted this 5-fold, and now the new absorption is 0.59. And you're gonna go, now what? Well, we're going to do the exact same thing. We're going to plug it in for y. Remember y, the absorption axis. We're going to put 0.59 equals 1.0469x, which is the x-axis, plus 0.0649. Bring this over again. 0.59 minus 0.0649. Remember, this is a plus, so bring it to the other side. It's the opposite. That's where we get the negative. Again, we've got our x with our value right here. We want to get x by itself, parentheses, order of operation. And then we bring this over here and get this. Oh my goodness, look at that, 0.5 milligrams per mil. Are we done? No, we're not, folks. We have one more thing to do. We diluted this, didn't we? We're going to take that number, multiply it by 5, and it's going to give us 2.5 milligrams per mil. Ladies and gentlemen, that is what our concentration is for sample number 2, 2.5 milligrams per mil. Any questions on this or on any other topic? If you have any suggestions for future videos, please email me at the email below. Thanks for watching. It's been fun, and I'll see you next time.